Okay, let's check out the set section of 3.10. You'll need your graphing calculator on this section. This section probably was pretty hard for you, I would think. Maybe not. Okay, so first of all, they would like us to graph f of x equals x to the third. You can do that right away. It is factored. The factored form is the exact same as the standard form here because x to the third cannot factor further. There is a root of 0, but its multiplicity is 3. And what that means is it will go through. It will not bounce, but it will hesitate, and the rate of change will slow down as it passes through here. 1 will be 1. 2, we'll go with 8. This is an odd function. It's an odd function because it has 180-degree rotational symmetry. 1, 2, 3, 4, 5, 6, 7. Yeah, I kind of missed that dot a little bit, but it's okay. The M behavior, it's a snake baby, a classic snake baby. Don't forget your arrows here. As x goes to negative infinity to the left, it is going down forever to negative infinity. As it goes to the right, it goes up to positive infinity. The degree is 3, and the value of the leading coefficient is 1. So that's a nice little warm-up. Take a look at what this triple root looks like because that will show up for the rest of your math career. Okay, now this time they give me factored form. I don't want to go to standard yet, even though I could, but factored form tells me the root, so I'm going to go ahead and do that. This x here says that 0 is a root with multiplicity 1, 2 is a root, and 4 is a root. All of those will show up as x-intercepts. They're all single roots, which means they will be straight pass-throughs. So I have a dot at 0, 2, and 4. The value of the leading coefficient is -1. You could see that easy enough. I can see that the degree is 3 and x times x times x. Some of you might not be able to see that until you go to standard form, and that's okay. So let's go ahead and go to standard form. I like to multiply these guys first. So I have a negative x times an x squared minus 4x minus 2x is minus 6x plus 8. Distribute the negative x, and I get negative x to the third minus 6x squared minus 8x. So the degree is 3, just like we saw here. This is going to be a negative snake baby, which means it'll flip upside down. Okay? And as x goes to the right, to positive infinity, it goes down. And as it goes to the left, it goes up. Now, I know that it's going to fit in here somehow. It's a negative snake baby, so it's going to like go whoop somehow, but I don't know how high or how low it's going to go. So this is when you will go to your technology. If you want to type both of these in to make sure you do them correctly, that's fine. I'm just going to type in what they gave me to start with, so I know that my graph is at least correct. Negative x, I have to turn my page here, times x minus 2 times x minus 4. Okay, now when you graph it, my zoom's messed up. I'm going to go ahead and zoom 6. That's what I thought was going to happen. Now, I'd like to know about how high or low these are. This graph has no maximum or no minimum, but there's turning points, which we call relative max and min. I will hit second, calculate minimum to find about how low this graph goes. Tell it where to start looking and where to stop looking. It will look between my two lines. If you want to guess, you can. And it goes down like 0.8, -3. So when I go back to my graph, 0.8, -3-ish will be about here. So that's about the lowest point it goes, and then it comes back up. And if you would like to know the highest point it goes, you'll repeat that process and do second calculate maximum. So second calculate maximum, which is 4. Okay, so let's start looking here and quit looking here. Hit one more enter, and there it is. It's like 3.1, 3.0. So, about 3.3. And that's fine. If you want a couple nice points, if you can find any, you also have the option of going to second table. Sometimes my kids like to find some of the nice points and dot those out if they want. That's up to you. This sketch is good enough. Number 12. This time they give me standard form and they ask me to graph it and behavior and all this stuff. Well, let's do what we know. I don't know how to factor it yet. I know what the degree is. The degree is 3. And I can do h of 2 by plugging in 2 into this equation. So that would be 2 to the third minus 2 times 2 squared minus 3 times 2. So it's 8 minus 6. So h of 2 is negative 6, which tells me that 2, negative 6 is a point on my graph. Now, I do know one of the zeros, because I said I don't know how to factor it yet, and I really don't, but I do know that x goes in there. So that leaves me with an x squared minus 2x minus 3, which means 0 is there. 2, negative 6 is there. And maybe I do know how to factor this. This is x and x minus 3, x plus 1. So that means I also have 3 and negative 1 as zeros. That dot really went over. Okay. What else do I know? It's a cubic, positive, so it's going to be a snake baby. As x goes to negative infinity, we're going down to negative infinity. As it goes to the right, it goes up. And I feel pretty good about this curve. I don't necessarily need to get a whole minimum here if I don't want to. How high does it go, though, to fit the snake baby? It's not going to go very high, probably. So maybe you just sketch it in like that. If you'd like to type it into your calculator to get more exact, that would be really good. X cubed minus 2x squared minus 3x. Okay. Yeah. I'm going to go ahead and erase what I have here for a second. Yeah, it doesn't go very high. Maybe it goes up to about 1, 1. Second, calculate maximum there. It's a little baby max. Start on the left to look, just like you read. Enter. Now, negative 0.5, almost up to 1. And then this guy doesn't get much lower than where we were. Second, calculate minimum. So our sketch with that h of 2 was pretty decent. And if you don't have a calculator, yeah, so 1.8 negative 6, yeah, it's really close to where it is. If you don't have a calculator, so what they're trying to explain here is if you don't have a calculator, if you just pick a point in between your zeros and plug in, you can get an idea of how low it goes. This guy, they just give me a graph and we're going to come up with the equation and everything. I thought this one looks like it's degree 4. Let's do the zeros first. Okay, the roots are negative 2, multiplicity 1, it's a straight pass through, 0, 1, and 2. And the y-intercept is 0. I'm going to guess the degree is 4. I definitely can do the end behavior. It's an up and up. It's going to infinity from both the left and the right. Let's try factored form because I believe it's a degree 4. That will be, let's do this x here first. So I have an x and then an x plus 2. I'm going to do the x minus 2 right by it because I like my conjugate pairs by each other. And then an x minus 1. We should be able to check that graph using our technology when we're done. But this will be x squared minus 4. So I have a x and then an x squared minus 4 times x minus 1. So it's an x cubed minus 4x times x minus 1. Double distribute that. I get x to the 4th minus x to the 3rd minus 4x squared plus 4x. And you can type that into your calculator to confirm that it's right. I'll go ahead and give you the spoiler that it is right. And that's the function in standard form. So x to the fourth minus x to the third, blah, 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 blah. Okay. 2 more of these, I think. This video is kind of long. Okay, 14. They'll give me another graph. Good. So let's see how we do here. One of the zeros is 2. Multiplicity 1, it's a straight pass through. Then we have a bounce 1, 2, 3, and I believe that's going to be a multiplicity 2, and it looks cubic to me. Okay, so I think the degree is 3. The leading coefficient, this is tricky. Definitely it's going to be negative. So sometimes I will guess first. I'm going to guess a -1 because it's definitely negative. The M behavior tells me so. If I go to the negative infinity, I'm going up. If I'm going to the right, I'm going down. These are my roots. So let's see what my factored form is. Maybe it's negative x and x minus 3 squared. But when you plug this into your calculator and you look, you will see it is not. This point is going to tell me that is not true. Look, y equals negative x, x minus 3 squared. So definitely check if you don't know what the leading coefficient is. Yeah, okay, so look at your table. The table says that 1 is at -4, and I can clearly tell that 1 is at -8. So I can't 1 -4, how do I get to -8? That's going to be a -2. So let's see if -2 is right. I think I can I think there's a way I can put second insert here, -2. There we go. And that's the graph I was needing. So there is a -2 leading coefficient. So instead of negative x, it's -2x times x minus 3 squared. To write that in standard form, it would be -2x times x squared minus 6x plus 9. Where's this coming from? It's taking x minus 3 times x minus 3 and double distributing. One more time through by distributing the -2x, and I get -2x to the third plus 12x squared minus 18x. Okay, and here's degree 3, snake baby. So I can do my M behavior. As x goes to negative infinity, it's going down. X goes to positive infinity, it's going up. The degree is 3. The y-intercept I can also get by plugging in 0 here, and I'm going to get 0, too. As soon as I see I is a root, you know negative I is also a root. They come in conjugate pairs. So that means x minus I and x plus I are factors, which is x squared plus ix minus ix minus I squared, which becomes a +1 when it's a minus a negative. So one of the factors is going to be x squared plus 1. How can I find the last one? Now, I could long division out, but you guys don't like that. So what you can do is you can type it in your graphing calculator, and you know one of them has to be real because there's no other way for a snake baby to be drawn without going through the x-axis. So what you can do is graph it and hope that it's nice, and you can see it on your table. So it's x cubed plus 2x squared plus x plus 2. And there's what the graph looks like, which you're going to have to graph anyway. And it looks like it's at -2. If I look at my table, I can confirm that it is at -2. So if -2 is the last zero or last root, then x plus 2 is my factor. And then you need to go ahead and sketch that guy. He was at -2 and 2. This is not going to be very good because I'm maybe like that. Okay, so that wiggle away told us those are imaginary. Okay, last 2 things on this set section. They just want you to finish it. If it's even, it has y-axis symmetry. So make this so that it has y-axis symmetry. It'll be like that. to make it odd as to have 180 rotational, and it would be down like that. Okay, that was a long video and a little tough, but we'll have the go as a separate one too.